Hello, statistics students. We're going to be talking in this video about conditional probability. And I want to tell you a little story in order to talk about it. So this is a story about a guy named Ross Douthat. He is a columnist for the New York Times, and he just wrote an entire article about how he thinks he tested negative for the coronavirus, but he actually has the virus. So this is called a false negative. Basically, he had been traveling on a book tour and he met hundreds and hundreds of people and was shaking their hands, and he came home and he started to feel shortness of breath, aches and pains, dry cough, but he didn't have a fever. His son and his neighbors all had the same symptoms, and his doctor actually told him that he had the virus, but then when he got tested, he came out negative, and so did his neighbors and son. So if Ross had the virus but tested negative, this again is called a false negative. And what you see on the right is actually from the Food and Drug Administration describing what a false negative actually is, and how it can happen. Like, the test is not necessarily perfect. So what could be the issue with a false negative when it comes to this deadly virus? Well, again, from the FDA, and this is a link if you want to go to the article, if somebody tests negative but they're actually sick, they might not receive the treatment that they need, and they might go around infecting other people. So this is actually a pretty big problem. So what is the probability of a false negative? What is the probability that Ross tested negative given that he had the disease? And actually, the way that we're going to frame it later is, what is the probability that he actually had the disease given that he received this negative test? Because that's what we don't know. We don't know if he has the disease or not. All we know is that he tested negative. So we'll frame it in the opposite direction. This is going to be your summative for this topic, so we're going to work through a different example. So suppose that one of your friends is called in for a drug test and he tests positive, so the school wants to kick him out. You claim that he claims that he didn't use drugs, so this would be a false positive. So if he actually did it and the test says he did it, they're right. If he did it and it says he didn't, that's a false negative. If he didn't do it and the test says he did, that's a false positive, which is the situation we're in right now. And if he didn't do it and the test says he didn't, then the test is right. So what's the probability of receiving a false positive? We need some information about the accuracy of the test. So let's say that the test detects 80% of drug users and it misses 20%, which means that it says it gives a negative for 20% of kids who are actually using drugs. On the other hand, for kids who are not using drugs, the test is accurate 99% of the time. So it will only give a false negative 1% of the time, or false positive 1% of the time. If you're not using and it thinks you did, that happens 1% of the time. So we fill out this table. Is this enough to know whether your friend is actually telling the truth, or the probability that he's actually telling the truth? We need a little bit more information. We need to know how likely it is that students are actually using drugs at the school. So let's add in some more information. If 10% of the students actually use drugs, now we can modify our table a little bit. So let's just pretend we're dealing with 1,000 people to make the numbers simpler. That would mean that 100 students use and 900 don't, which means that of those who use, the test will be positive for 80 students and negative for 20 students. Of those who don't use, the test will be positive for only 9 students and negative for 891. So what is the probability of getting this positive result? They say he did it if he didn't actually do it. Well, it'd be 9 out of 89. That's about 10%. So that's a 10% chance that he didn't use. That's pretty good. He's got a case to argue. So now let's look at it in a slightly different way. This is using trees. So the idea with trees is I separated it into all the different cases. So use, not use, that's going to be 10% and 90%. If you use, you test positive 80% of the time, test negative 20% of the time. So that's why I labeled those branches that way. If you do not use, you'll test positive 1% of the time and negative 99% of the time. So that's why I labeled those branches that way. So first we're going to calculate the two probabilities of testing positive. We do that by just multiplying along the branches. So by the addition rule, the probability of testing positive is 0.089. The probability of testing positive given that you don't actually use the drug is 0.009. So we take that fraction, we get approximately the same thing. So that's just a different way of viewing it. So now here's your challenge. In a recent study of Chinese patients, the coronavirus test detected only about 60% of coronavirus cases, meaning the accuracy of a positive result is 60%. So first I want you to think about what is the rate of false positives. Then let's suppose that the accuracy of a negative result is 99%. So what is the rate of false negatives? And you're going to use that to fill out this basic table that's similar to the one we did here. Then we add the additional information. Ross Douthit is from New York City, where there are currently 33,066 cases, and the population of New York is approximately 8 million. So what's the probability of actually having the virus in New York? Then I want you to find the probability that Ross had the disease given that he tested negative using either the tree approach or the enhanced table approach. So that is your summative assignment. Let me just quickly show you the page for topic 3. This video will appear right here, and you've got a Khan Academy set or an IXL set to do based on these 3 videos. So that's all from me on topic 3 of Unit 7. Please let me know if you have any questions.